Hello and welcome to the Energy Resilience Lab. Our lab is dedicated to giving you the knowledge, skills, and the encouragement that you need to become energy resilient and energy independent. Today we'd like to jump into an informational podcast where we're going to look at a very small energy storage system, which is the AirPods from Apple. Samsung and all the other companies also have AirPod type products where you have a base unit, which is the holder that has an energy storage system in it, and then you have your actual earbuds that go into your ear and play the audio for you. So this system is all DC, so when you supply power to it, either through wireless charging or through the USB, you're supplying DC power to the system. The system then uses pulse width modulation and maybe some buck and boost technology to take the power in. So if you're using a USB-C charger, it can sometimes supply more power at higher voltage. USB-C chargers can be capable of supplying 5 volts, 9 volts, 12 volts, and then also 20 volt level. It does this to maximize the amount of power that you're getting from your charger, USB charger, to your device. So in this case, if you're supplying 9 volts to the system, it will buck that down to be at the charging voltage of the battery. Usually in very compact systems like this, you're going to use a lithium cobalt battery, nominal voltage of 3.7 volts. So you have to buck the 5 volts or 9 volts down to the 3.7 volts to charge the system. So Apple takes care of that. It charges the main battery, and then from there it will buck and boost the internal battery to charge the AirPods. I haven't torn this down. It may be that the battery in the case is 2 batteries in series. So that would be 7.4 nominal battery voltage. In that case, you just have to buck it to get to the single cell in the AirPod itself. With this system, you're charging the case. With most of the Apple products, they maximize the charge at the start. So you can charge above 1 times the capacity of the cell, which means you can charge faster than an hour for the first part of the charging period. So usually with the iPhone, it will slow down above 80% to maximize the life of your battery. But before that, you can put a lot of energy into it. So from that, we'll fast charge the case for a portion of the time, then it will go to just the standard 1-hour charge. And then the new features that Apple has added is they have a protection on this where you can select if you want to be more green. You can choose to charge your AirPods and your phone and your laptop and maximize their performance when they're connected to the grid, only when it's most advantageous on the grid. So Apple has an algorithm to say when the solar is being provided to the grid, and it will preferentially use the energy during the time when the solar is produced. Or in my area, there's a lot of hydro, so that's 24/7, but sometimes it will go higher. Like right now, when there's a lot of snow runoff, the hydro can run at a higher rate if they're kind of a low head hydro and they have a lot of runoff from the mountains. So it'll peak in the evening and then fall off in the morning. So Apple takes care of that and lets you choose if you want to be more earth friendly when you're charging your system. In addition, with this system, it maximizes your uptime. So having this energy storage system built in with the AirPods, you're able to get 30 hours of music, 24 hours of phone time if you're communicating back and forth. And just the AirPods themselves run between 5.5 and 6 hours. So 5.5 hours of phone time and 6 hours just playing audio if you're listening to something. So the reason that they do a little energy storage system for your AirPods is so that you have enough energy on the go so that you can travel, essentially world travel. So if you have 30 hours of battery life, you can essentially circumnavigate the globe in an aircraft and still have your music playing. So that is very convenient. In addition to that, if we're camping or we're out and about and we don't have a charger all the time for our system, it just gives us that resilience so we can keep going maybe for a few days, part-time listening to things. So that's kind of the purpose of this energy storage system. Between the case and the AirPods, you're able to plug in your AirPod, and the little contacts are on the opposite sides of the stem there. So when you drop it in, it recognizes that, and that's where it supplies the plus and minus to the system to charge the battery. This system, when it's fast charging, so if your AirPod is totally extinguished, there's no energy left to run, it'll shut down and go into energy conservation mode, protect the battery. And once you drop it in here, it will fast charge, and according to Apple's documentation, you can put it in here for 5 minutes and get an hour of audio time. Back calculating that with the 5.5 hours of runtime, the AirPod is charging at about 2.2 C, which means the battery has a certain capacity of maybe 100 milliamp hours, and we're going to charge it at 222 for a 2.22 C charge, just for that first 5 minutes, to give you that first hour of music with just a little charge time, so just the 5 minutes. So I don't know about you guys, but I will run out of power with my AirPods, and I will alternate. So when they ding, they'll just make a sound in your ear to tell you that the energy is almost gone and that it's going to have to shut down. And so I'll leave one in and keep listening or doing what I'm doing, but I'll take the other one out and just drop it into the charger. And so that will charge that one quickly and give me an hour of music time. And then once that's got that hour back in, I'll put that one in and drop the other one into the charging case to give it a little energy so I can extend my listening time. So this is a very simple case of kind of off-grid energy storage system. You can use this in the wilderness. You can use it while traveling with air travel. And it's just a really neat and convenient product for you to kind of maximize your usage with your phone and your music or podcast, whatever you like to listen to. So there's a simple energy storage system that I wanted to show you and just walk through kind of the ins and outs of how it charges and how long it lasts. We're going to be stepping through a lot more little energy storage systems, kind of ranging all the way from the smallest to the largest systems, and we'll just describe what they are and how they can be helpful to make you energy resilient. In this case, having this case gives you resilience for essentially a day. So you can go without power sources somewhere for a whole day and be able to communicate with your AirPods, which is a pretty significant achievement. So Apple was able to efficiently make a system that runs for 6 hours and then augment it with an energy storage system to get you all the way out to the 24 hours. So if you're traveling a few days part-time, or if you want audio the whole time, it'll last you a whole day. Thank you guys for watching, and if you guys have any devices that you'd like to know how they work or what capacities they have, I can do a little research for you guys too. Just drop your questions in the comment section and I will get to them as I can, and we'll do shows to update you on how those systems work. Thank you guys, and have a great day. We'll talk to you later. Thanks. Bye.